It's a little more work than you're probably used to. It's not just like, just basic plug stuff in. But let's do the example first, and then we'll do a couple of things from the homework. And the homework's going to make a lot more sense to you when you see this example. I think when I taught this lesson, we were running out of time. Let's listen. I'm talking, please. All right, so let's do the example. I'm not going to draw all the trees and all that kind of stuff, but they draw everything for you. Do you see all the red lines and stuff? Page 576 is what I'm looking at. It's on the top. And let's just draw the lines. After you get used to this, now maybe if you tried this from scratch, you just saw this problem and just tried it, my guess is you probably wouldn't have been able to figure it out. But after you see it, I think it might start making a little sense to you. So it looks like this. This is a right triangle right there. And let's put some letters in here so we can refer to some things. A, B, C, D. And they tell you some things. They actually ask you, well, let's do this in another color here. Let's go yellow. Let's see what they tell you. They tell you that this angle right here is 70 degrees. This one right here is 26 degrees. Not exactly drawn to scale, but it's okay. DC is 10 from here to here. So from here to here is 10. And that's all they tell you. And you're trying to find, this is a tree. This AB is the height of a tree. And yeah, they tell you the 1.7. I'm not even going to worry about that one right now until the very end, okay, until we get to the end. Let's just say this is actually not the height of the tree. This is from the person's point of view, right? Like their eyeball would be right here. They're actually standing on the ground, which is down in here. So the tree actually goes down a little bit further than this. But we'll talk about that at the very end, okay? That's really not that hard of a thing to do. The hardest thing to do is to solve for that right there. So solve for x. All right, so this is what you have. And the problem that we started yesterday, do you remember that? We really didn't get anywhere with it. It's set up almost identical to this. It really is. Okay, so if we can do this example, you should be able to look at that problem that we started yesterday, and it's really identical to this problem right here. So where do you even start? I mean, you have a right triangle, so that's nice. You actually have two right triangles, don't you? You got this little one right here, ABC. Everybody see that with the 70 degree and the 90? And you also have what else? AB what? D, right, ABD, all right, which is this triangle with a 26 degree angle. You with me on that? But look what they tell you. They only tell you one side. And they don't even tell you the whole side of this. They don't even tell you the whole entire length of this side of the triangle, do they? So that's kind of hard. Now look, if they would have told you BC, that would have been real nice, wouldn't it? And then you could have figured out this, then you could figure out the whole side. That would have been a piece of cake. That would have been hard at all if you knew BC. Problem is, they don't tell you BC. That's what makes it a little bit tougher. So let's show you what we're going to do. Let's name BC. Let's name it Y. Is that all right? Just because we're going to use it. And so I want to name it something. And it's a little easier just calling it Y than calling it BC. Don't you think? So I'll call it Y. Now watch what we're going to do. Let's just take a look at this triangle ABC, this little skinny triangle with a 70 degree right here. If I wanted to solve for x, now I realize I don't know this, okay? So we're not going to get an exact answer. We'll get it in terms of something else. But if I wanted to solve for x, and I wanted to use this angle right here, which trig function, could I possibly use? Using this side and this side right here. Opposite over adjacent, which is tangent. Very good, okay? But the problem with that is I don't know what y is. Agreed? But let's set it up anyway, and I'll show you, and it'll kind of fall into place here. So let's take the tangent of 70 degrees, and what would that equal? That would equal what over what? X over y. Okay. Now, since I'm trying to eventually solve for x, let's actually take this little formula right here, this little equation, and let's get x by itself. All right, so if we wanted to get x by itself, what would x equal then? Right, but we always put the y out in front, right? So I'll take this y, put it out in front. So x is equal to y times the tangent of 70 degrees. And you say, well, that doesn't help me because I still don't know what y is. So why would I even go through this? Well, because I'm going to do the same thing for the other right triangle. Remember, there's two right triangles. There's this ABC, and there's the big one, the whole entire one, ABD. Are you with me so far? Yeah, I haven't done that much so far. So what we're going to do is we're going to kind of do the same thing, but we're going to do that with the 26-degree angle. All right? Right there? Okay. So I want to do the same thing with the 26-degree angle. So what did we do with the 70? We went opposite over adjacent, right? So what are we going to do with the 26? Now look, again, I want to solve for x, don't I? And this x right here is the same x as it is here, isn't it? All right. Yeah. So let's do this in another color to separate it a little bit. So let's do this. The tangent of what? 26 degrees equals opposite over adjacent. So the opposite is x over the adjacent. Now what's the adjacent? Is the adjacent just 10? That's right. It's 10 plus y. It's the whole entire leg of that right triangle, isn't it? So you could put 10 plus y or y plus 10. I'm going to put y plus 10. Is that all right? Just like the letter first, that's all. You'll see how it's going here. Now, what did we do here? We solved for x, didn't we? We got x by itself. Oh, you know what I forgot to do? I like to put this in a box, because we're going to come back to it later. All right? I put it in a box, come back later, then I'm going to use it. And I'll show you. Now, what do you think we're going to do here? We got x by itself here. What do you think we could do over here? Get x by itself over here. So that wouldn't be that hard, would it? So x is equal to what? Y plus 10. Now, that's being multiplied, right? So if it's a sum, I always like to put that in parentheses, because that does make it different. Times what? The tangent of 26 degrees. Because if I didn't put the parentheses, what would it be? It would just be y plus 10 times the tangent of 26. That's different than this, isn't it? Do you agree? Yeah. All right, now I'm going to put that in a box. Why do I put them in a box? Because look, this is equal to what? X, and this stuff right here is equal to what? X. Now the x is the same thing, right? It's the same variable. So what do you think might be true about this stuff here and this stuff here? They're equal to each other, aren't they? Right? Because they're both equal to the same thing, right? Everybody with me on this? Okay? They're both equal to this side right here. So what I need to solve for y. Do you remember in Algebra 1, we talked about this the other day, substitution, elimination? Remember that? This is kind of like substitution. It's not kind of like it. It is. It's exactly substitution. It looks a little different than what you were used to in Algebra 1. You never had stuff that looked like this. But the idea, the whole process is the exact same thing as substitution. So look, if this is equal to x and this is equal to x, what's true about these two things? They're equal to each other, aren't they? So let's set them equal to each other. And then what can we solve for then? We can solve for y. All right, let's do this in green. Yes? Yeah, you could still solve for x, but your math would be a little bit different though. Like if your x was on the bottom here and this was on the top, then you would bring the x over here on top and you take this tangent 26, put it on the bottom. But it's not, so we won't worry about that. So we just set these equal to each other, right? Because this is equal to x, this is equal to x. Set them equal to each other. Then you can solve for what? For y. Remember what we said earlier? If I knew what y is at the beginning, this wouldn't have been hard at all. But now, guess what I just did? Well, I'm going to in a few minutes here, or a few seconds. I'm going to solve for y, right? So now I will get y. So I'm going to set these equal to each other. So it's y tangent of 70 equals what? Y plus 10 times the tangent of 26. Now, I know it looks a little weird, but we can actually solve for y. Right? Because it's the only variable, isn't it? Tangent's not a variable, is it? Nope. It's just a word that describes a ratio. So, and look, this tangent of 70 is just a regular old number, isn't it? I can put it into a calculator and just get some number. This tangent of 26, same deal, isn't it? Right? I can put it into a calculator, get some number. So really, this is just like having a regular number. Don't write this down, but watch. It's kind of like this. It's kind of like, I just made up the number 3, all right, just to represent the tangent of 70. Because all this is a number times y, isn't it? Well, there's a number times y equals, what's this? This is a little sum, right? We'll put y plus 10 times some number, right? I don't know, 12 or something, okay? And look, you'd be able to solve for this, wouldn't you? isn't this really the same thing as this? Except the only thing that's a little bit weird is the tangent of 70 is just some decimal number, right? If I put the tangent of 70 into a calculator, I just get some decimal. Why are you looking at me like that? why don't you see that? Well, you will. I haven't even talked about how to get to it. I'm just trying to get you to just stick with me. You're going ahead of where I am. That's why you're confused, because you're thinking of stuff I haven't talked about yet. Okay, I just want you to stick with me right now. Wouldn't you agree that this is just a number? Yeah, because watch. I put it into a calculator. Tangent of 70. Tangent 70. And there it is. It's just some number, 1.2 something, right? So that's just a regular old number, 1.2 something. This is some number also, whatever. I don't even care what it is. If they were just regular old numbers, it wouldn't be hard at all to solve for y here, would it? Distribute this, get y on the same side, and everything else. Yes? Well, maybe I'm in the wrong mode. Yeah, here we go. Yeah, I know. Because I got it in radians instead of degrees. I'm just showing you right there. Right? Because remember, my default's to radians. I don't know why. And I just stuck that in there. So, all right. So, forget about the 1.2. That's not really the point of what I'm trying to say. The point of what I'm trying to say is this: is that the tangent of 70 is just some number. All right. The tangent of 26 is just some number. If this was just a regular number and this was just a regular number, you could solve for y very easily, couldn't you? It's the same process. It's the same exact thing, except it just looks a little weirder, that's all. Okay, it's just not a nice, pretty whole number like it would have been over here. Does that make any sense at all? All right, that's all I'm trying to get you to do, because I'm getting looks. Some of you guys are getting it, and I know I'm going over this too much, but some of you guys are giving me looks like I have no idea what you're talking about. So that's what I'm trying to do here. So let's solve. So I'm just going to keep this the way it is. And we just said right here, this is just a number. What do I do with this? I distribute it. So it's going to be y times the tangent of 26. Now, I'm not using my calculator until the very, very end. All right? I am not putting this into a calculator, rounding it, and putting it right here. I'm going to wait to the very, very end, put it into the calculator all in one shot. So this is going to be plus what? 10 times the tangent of 26. We good? All right, what do we want to do now? We want to get y on the same side, don't we? So let's do that. So we subtract it. No, not divide, because this, you got to get rid of this whole entire thing right here. So you have to subtract it, right? It's being added, so we subtract it. Like if this was a 12y, right, and this was a 3y plus 120, how would you get rid of this 12y, or how would you get rid of this 3y? You would subtract, wouldn't you? You wouldn't divide. It's the same exact thing. So I'm going to put everything on the left-hand side. Makes it a little easier, I think. So we subtract y tangent of 26. Now in algebra, I would have put minus y tan 26, same thing over here, but at this point, I know that it cancels out, and so I get this. Equals what? 10 times the tangent of 26. Do you agree? I just subtracted this from both sides, and it canceled out from this side, but it went to the left side. All right? I got a y here and a y here. Might have not done these problems in a while, but I'm sure you did this in Algebra 1. You have a common factor, don't you? Right? So what can I do if I have a common factor here? Now, I can't add them together. Well, I mean, I guess technically you could, but I am not going to put this into a calculator right now. You can't subtract 26 from 70. This is the tangent of 70. This is the tangent of 26. It's not just a regular old 70, and it's not just a regular old 26. I can't subtract those from each other. Nope. You can't put them together? You can't just combine y nope. Times the tangent of... I mean, if you stuck this into a calculator and put this into a calculator and then subtracted them, yeah, I guess you could. But again, I don't want to use the calculator till the very, very end. That's what I'm getting you to think. Think Algebra 1. What's that? I want you to think. I want you to think. I don't think you thought enough. No, because this is something... No, this is kind of like this. Watch. Listen. Okay, shh. Settle down. Easy. Okay, take it easy. Watch. What if this was 5y minus 2y? Do the y's just cancel out? It's 3y, right? Okay. But this is going to be some crazy decimal. You don't know exactly what that is, right? And this is some crazy decimal. You don't know what that is. No, you can't do that. Because you can't just say 5 minus 2 is 3.
Interruption. Middle school baseball and middle school softball.
It's
You're now
3y.
dismissed.
Let me just show you then. All right. What? Uh-huh. Nah, you're not going to divide anything. Well, it's kind of division, but it's... I'll show you. Everybody watching? Michael. So what we're going to do is we have something in common with both of these. I'm trying to think of something that you might have seen in Algebra 1. Like, I don't know, 3x squared plus 5x cubed y. Do you remember doing something like this? And it said finding the greatest common factor. Do you remember this? Sure you do. If you think back, I know for a fact you did this in Algebra 1. You absolutely did this. You absolutely did this in Algebra 1. You might not remember. You may not remember, but you did. What you do, you look for a greatest common factor. What's in common with this and this? There's an x, and it's not two x's. How are we going to say it? There's an x squared in common. So what do we do with that x squared? We factor it. You didn't do any factoring in Algebra 1? You factor it out, and what do you get? If you factor out... I got like 10 people yelling at me. What's going on? Let's take this... Let's calm down and just watch. So you factor out an x squared, what are you left with? You're dividing this by this, so you get a 3 plus 5. Right. So you did do this, okay? So you have done that. This is the same kind of deal. So look, I got a y in common here and a y in common here. So if I factor out a y, what are you left with if I factor out a y? That's right, the tangent of 70 minus the tangent of 26. Now you can't just go 70 minus 26. I'm not even going to explain why you can't. You just can't, okay? Because we got enough to do. And then we get all this. Okay? But I want you to understand things. I don't want to just say this is how you do it, just memorize how to do it, okay? That's not a good way to learn how to do things. You're not really learning how to do anything. You're just being a little robot and just doing what you're programmed to do. I want you to go beyond being a robot. I want you to be able to think through why you're doing what you're doing, okay? So look at this. Now we have y by itself, don't we? We don't have two different y's here. What is all this stuff in the parentheses doing to this y? It's multiplying. How do we get rid of something that's being multiplied? We divide. So we divide by this. And without showing over, watch, this is what we get. So what's on the right side? It's this right here, isn't it? Over what? All this. Right. Tangent of 70 minus the tangent of 26. Alright? And that is what you're going to put into the calculator. And that's not even our final answer. That's just to find the y. Okay? But let's put this into a calculator. Shh. You guys flip out so easy, okay? It's just, you've done this before. You guys have flipped out on things before. Okay? But then after a while, after you get used to it, then it's yeah, we're kind of in the middle of something right now. And you've seen before, when you guys are like, oh no, I can't do this, it's too low. And then after you do it a couple times, you're like, okay, that wasn't near as bad as I thought. Well, maybe this is going to be the same way, don't you think? All right, so let's put this into a calculator. There's several different ways you could do this. Here's how I would do this. If I had a calculator like this, I would go 10 tangent 26. All right, then hit divide. Now, but I'm dividing by all this, aren't I? So what I'm going to do is I'm going to put that in parentheses. You with me? So I'm going to put that in parentheses and then go tangent of 70. I'll close that parentheses right there. Do you see it? It put a parentheses before the 70. I always like to close that. I don't know why. I just do. Minus what? Tangent of 26. I like to close that parentheses. Now remember, this whole thing was in one big parentheses. So I'm going to put another parentheses. Do you see what I just did? Do you see why there's two right next to each other? That first parentheses just contains the 26. This last one right here groups the whole entire denominator. And now I should be able to get an answer. And then it's about 2.16. Okay? We'll show you in a sec. It's approximately 2.16. Now, if you had a now watch, if you have a TI 30XA, you kind of do the same thing. The parentheses button is very, very important. Okay, so watch. If you have a 30XA, I would do this. I would hit 10 times and then 26 tangent. Doesn't matter. Listen to me. You can do either way. Listen to me. Okay. Hit 10 times 26 tangent, but then you got to hit equals. All right, and that gives you whatever the tangent of 10 times the tangent of 26. Then you hit divide. Then you hit a left parentheses. All right. Then you hit 70 tangent minus 26 tangent. Close the parentheses. Put a right parentheses. Hit equals, and you should get 2.158.
What number is this?
This is an example. So we'll just keep that 2.16. So let's go back up to here. And what was y? 2.16. Now look, it's taken me, it takes me 3 times as long to explain the problem than it does to do it, okay? And we'll do one from scratch without hardly any explanation. I'll tell you what I'm doing, but I won't go through all the explanations. And you'll see how much quicker it really is than all this, okay? No, because we have to find how tall this tree is, right? And so from AB is what we want to find. But that's the hardest part. The rest is actually kind of simple. Because look, you guys watching? Because now, remember what we said earlier? If I knew what y was, this wouldn't be hard at all. Because now I can solve for x. It's only really one step. We kind of already did it over here. We already have x equals a couple things, don't we? X equals y times the tangent of 70. So what do? Just plug it in. That's right. I mean, you could plug it into this one. That'd be dumb, though. I'd put it into this one. That's the easiest one, right? So you just plug it in. So x equals y, which is 2.16, right, times the tangent of 70. Plug that into a calculator, and you've got x, and you've got your answer. And that's about 5.9, right? You can do that on a calculator. That's not hard. So x is 5.9. Now, well, the question on that says, find the height of the tree. Now, remember what we found. If you look at the picture, this only goes to the height, the eye level of the person, right? And so here's the person right here. So there's their eyeball, and there's their feet, and the ground's right here. Does it tell you how tall the person is? Yeah. This is in meters all, by the way. So it's 1.7. So the height of the person, right, here's the ground level. There's the person, stick figure person, put an head right there. And the person is 1.7 meters, right? Well, from the eyeball to the top of the tree is 5.9 meters. The person is 1.7 meters. So what do you do to find the whole entire height of the tree? Just add the two together. So that's what, 7.6? Okay. What? It was here, but I just moved it here so I could see the person right under the tree. Doesn't make any difference. Okay. I know they're not actually standing here looking at the tree from here. They were here, but I just put it here just so you could see that little length. Okay, so that would be the answer. That's how tall the tree is. Okay, 7.6, or they said about 8 meters. Okay, so around 7.6 meters. So let's do another one from scratch. Okay, let's do that one we started yesterday. That's a very good possibility. If I spent all this time on it, I wouldn't have any problem. I wouldn't put 5 of them on there, but I could have 1 on there. Sure, I could have 1. All right. Let's see. We were doing 8. Okay. I actually did it yesterday so that I could stay on track. I wouldn't have to, if I messed up, so I wouldn't mess up. Alright, here's the thing. Now, number 8, it's that pyramid problem. Okay? So basically, I'll tell you what, it's going to eventually just look like a right triangle. Alright, but I want to show you what's going on. Here's the ground. Here's the pyramid. Let's Let's make that a little taller. Okay. And there's two people standing on the ground. Now, I think you have to make an assumption with this. Yeah. Yep. Watch, I think you have to make a bit of an assumption that the people are the same height. Alright? So remember, one person was standing 20 feet. Alright, Tiffany, you're not in this class, hush. Alright, so let's take a look. So this is the angle that this person's looking at the top of the pyramid, and this is the angle that the other person is looking at the pyramid. Do you understand what I'm drawing here? These are the two people, okay? Nope, I'm not going to. That's because it'll just get too confusing. That's the height of one person. This is the height of the other person. It says they're 20 feet apart, correct? So we'll put a 20 right here in between here and here. All right? And it tells you the angles that they're looking at the pyramid. This first person right here was looking at 50 degrees, and this person right here was looking at 48.6 degrees. But we need something, don't we? We need a horizontal to be able to talk about that angle. Everybody see that? So what angle, let's use different colors so it stands out a little bit better. So that person's looking up at the top of the pyramid at a 50-degree angle. This person that's 20 feet behind them, that angle is going to shrink a little bit, isn't it? And that's 48.6 degrees. And if you look at this, this is the exact same problem that we just finished doing. And you want to find how tall the pyramid is, correct? What's that? It's not 20y. This would be the y right here. Okay? So like from here to here, and let's put it up here. To tell you the truth, do we really need the bottom of this whole section? We've got it all figured out. We've got our triangles, don't we? All right. So what is this right here? This is not the ground. This is their eye level, isn't it? All right. So the pyramid actually starts here and it goes all the way to the ground. But what we're going to do is we're just going to find this X right here. Now, they don't even tell you the height of these people. They should have. But you could kind of round it, right? Because they say about. The answer says about. So they round it quite a bit. But to tell you the truth, do you really need all this stuff down here on the bottom anymore? You don't really need that. You don't need that. You don't need any of this. And let's just move this up about right there. Okay? And this is 20. Everybody with me so far? So that's what's going on. The picture is a little tough to figure out, but that's what's going on right here. This is X. What are we going to have to find that's not really given as a variable? We're going to have to find this distance from here to here, aren't we? And we'll call that Y. We'll stay consistent with the same numbers. Letters. But they actually stand for numbers though, don't they? But you're right, they are letters. Isn't this the same exact problem that we just did? Just different numbers and the letters are the same, but the numbers are just a little different, that's all. Alright, so let's go through it and figure out what we're going to do. I'll go a little faster than what I did before. Okay, first of all, we'll take this one right here. You could start with this one as well, but I like to start with this one. What can we figure out? We can go opposite over adjacent, can't we? Which is the tangent. So the tangent of 50 is equal to the opposite over the adjacent. I'm going to put that in a box because I'm going to use that a little bit later. Actually, let's solve for x first, then we'll put that in a box. So x is y times the tangent of 50. I'm going to put that in a box. Then we do the same thing with the big triangle, with the 48.6 degrees. Absolutely, because we have to set them equal to each other. If we didn't use that, yeah, yes. Because it's a right triangle. This is opposite and this is adjacent. We just used the tangent. This is opposite, that's adjacent. That's what we did right there. And then all we did was solve for x. We just got x by itself by multiplying both sides by y. Okay, it's not like I just memorized that. Okay, we looked at it, we looked at the right triangle, we figured out how to get that. Let's do the next one, the 48.6, this angle right here. So we used the opposite of 48.6 is this side right here, isn't it? Alright, so that's x over the adjacent. The adjacent is this whole thing from here to here. It's not 20y, it's what? It's 20 plus y, or y plus 20. Now we want to get x by itself, so we multiply both sides by y plus 20. So x is y plus 20 times the tangent of 48.6. Look what I have. I've got this equal to x and I have this equal to x, don't I? So I like to put them in a box so you can really see what's going on. Yeah, if they're both equal to x, they're both equal to each other. So we go y times the tangent of 50 equals, I'll tell you what, let's just distribute right now. Is that all right? Save us a step. So we distribute. So it's going to be y times the tangent of 48.6 plus 20 times the tangent of 48.6. All I did was distribute, and I got this. Set them equal to each other. Why did I set them equal to each other? Because they're both equal to x, so they must equal each other. Now I have to get y on the same side, so I subtract this from both sides, right? Tell you what, with the magic of my little program here, I'll just put a minus here. Is that all right? Does that bother you if I do that? I just subtracted that from both sides. Okay? You could do the step if you want to. Now, what do we want to do? We want one y, don't we? We don't want two y's like this. So what's the word? What do? Greatest common what? Factor, right. We're going to factor a y. So we factor out the y. What do we get? We get the tangent of 50 minus the tangent of 48.6. Right, equals all this. 20 times the tangent of 48.6. Now, we're ready to get y by itself, aren't we? So how do we get rid of it? Divide all this stuff. So let's just keep that right there and just divide it by what? The tangent of 50 minus the tangent of 48.6. And that's what y is, right there. Plug that into a calculator, and I've already done this, and you get about 394.7. All right, try that. So that's what y is, 394.7. Let's put it back up here. Getting tired of yellow. Let's go to this color. So this is 394.7. That's what y is. But what are we trying to find? We're trying to find x, aren't we? We already know what x is equal to, right? So let's just take our 394.7, which is y, and then we're going to put it in for this. So what's x equal to then? It's 394.7 times the tangent of 50. Put that into a calculator, and you get about 470 feet. See? And that is the height from here to here. Okay, that's right. Remember, there is somebody standing. Remember, this is at eyeball level right here. Okay, the ground is actually here, isn't it? Now, they didn't tell you the height of the person, but, I mean, what do you think let's give an average height of a guy. I mean, they're two guys, right, because they tell you the names. Let's say 6 feet, okay? So I'd say 470 feet is from here to here. If you add another 6 feet, what's the whole total height of the pyramid? 476, okay? They say 470. Their answer that I gave yesterday said 470, but they don't tell you the height of the people, right? So, but it says about 470. I mean, 470 and 476 is awful close, wouldn't you think? Yeah. So 470 is perfectly fine. Yeah. Because we don't know they're 6 feet tall, do we? Right? They could be 3 feet tall. I don't know. Little people or something. I don't know. And that's how you do it. Now that was a lot quicker, wasn't it? The second time that we did it, and it's not so bad after you see those relationships. Now you're going to have several other problems. You're going to be doing the same kind of thing, all right? So you will be able to practice that a little bit more, all right? So now you know what you're doing. Now this is like the third day for this homework, but you really haven't known what was going on with that homework. So this tonight is for real, okay? For real, I want you to get these homeworks done, and now you have enough information to be able to get that homework done, okay? Yeah, absolutely. Start from scratch, yeah. That's what I would do. I would just start from scratch and do the same exact problems. 4 to 11.
Just wanted to make an important
okay?
announcement.
So
the Joe
4
Feely
to
field
11.
dedication is going to be held today at 3:05 on the varsity baseball field. So please come out to support that. That's 3:05 on the varsity baseball field. Also, just another announcement, the Red Lion 2012 football team members going to the Naval Academy tomorrow should be in front of the main entrance of the school no later than 1:45 tomorrow. Thank you.